They make music, okay? It has 2 wires. You learned that in class. So could you start by drawing your wires? Where do those wires go to? There's a comb. Good. What does the comb do? So that's what I want you to do. If you get stuck, think about, what do I know? What do I know from my own life? And then move forward. Okay? All right, keep going. Start with drawing it, right? And what you know about it. Once you know what you know, then we'll break it apart. That's all I'm asking.
Okay.
Electricity
You touch the switch
through the wires
and
by
then
the radio station.
since there's
Okay.
energy, it goes
So you said, what did you say it definitely
and then
needs?
it goes through wires.
Definitely needs a radio station
No, it'll hit the.
send
It's like
electric wave to
Do we have it right now?
So what about a speaker at your house? If you have a speaker that's just sitting at your house, is it attached to a radio station?
No.
The sound thing.
So what do you think happens with the speakers that are at your house?
It gets the electricity from the generator from your house.
Okay. So maybe you could start there, right? Start with what you know and draw. Then where does it go from the generator? How does it get to the speaker?
It goes through the wires and into the speaker and then projects.
Okay. So do you know where to start with your drawing now? Good job. Go. Good. Lydell, go lead vocab. Lydell will tell you what words to say. Don't forget your hands.
Electric current.
Electric current is the flow of electricity through the wires. Circuit is the pathway through which electric current flows. Components are the specific places in the
I think 2 people were reading the wrong definition. We are on what word, Lydell? Components. Components
are the individual parts in the circuit. Transfer is to move. Contact points are the specific places that the wires need to touch the components. Closed circuit.
Freeze. Freeze. Closed circuit. Just tell me. Why is this work? What's special about the closed circuit? What's special? Using your arms. So if you need to use your arms in your discussion, use your arms. Lydell, pick someone. Your teacher.
It's special because it won't escape because it's closed and there's no way out.
Okay, Inwan said special because it can't escape. There is no way out. How do you know there's no way out? Using your arms. Someone tell me. Avery.
Because they're touching.
They're touching. Can it go anywhere else?
No.
No. All right. What's the next word, Lydell?
Open circuit.
Open circuit.
Freeze. What's special about your open circuit? Lydell, pick someone.
Open circuit is when it doesn't allow energy to flow.
It doesn't allow energy to flow. Is Brandon correct?
Yes.
Why is Brandon correct? How do you know using your arms that open circuit does not allow energy to flow? Pick someone.
Because it's open and there's no way the energy could even get to the next part of the circuit.
Good. So if I have my hands like this and they're frozen, Maddie says there's no way for energy to get from here to here. Can you if they're frozen?
No.
Can it just skip over to this arm?
No.
No. So in an open circuit, does energy flow?
No.
No. Good. Go on.
Conductor makes a closed circuit and lets electricity
wires and it won't escape. Why is it important the energy does not escape? Why is that?
So we can have power.
So we can have power. How do we have power if the energy doesn't escape?
Because if the energy will be going out of the wires and they would not work because the energy won't get from one place to the other.
Good. Without an insulator, it wouldn't get from one place to the other. Go on, Lydell.
Series circuit.
Series circuit. When the electric current goes through all of the components, one after the other.
How many pathways in a series circuit?
One.
Do they all share energy?
Yes.
What happens if one light bulb burns out?
All burn out.
Good.
Parallel circuit.
Parallel circuit. Whenever a circuit splits and goes to two or more components.
How many pathways?
Two or more.
Do they share energy?
No.
What happens when one light bulb burns out?
The rest stay on.
Good. The rest stay lit. The rest stay on. Go on.
Attract. When two magnets pull and stick together.
What two poles pull and stick together?
North and south.
Good.
Repel. When two magnets push each other away.
What poles repel?
North and north or south and south.
Good. Thank you, Lydell. All right. So how did you guys say yesterday? How do we say we're going to change the strength of our electromagnet? How did we say we would change the strength? Would we make it stronger or weaker? Tell your neighbor. All right, give me 5. What do we say? How do we say that we change the strength? How do we make it stronger or weaker? Malaya.
By making it stronger, you wrap the wire around the rivet more times, and to make it weaker, you don't wrap it around as many times.
Good. We said to make it stronger. We wrap it around more times to make it weaker. We don't think we wrap it around as many times. Give me a thumb if you remember talking about that yesterday. That's what you guys guessed, right? So have we investigated this yet, though? No. To be a scientist, we have to have our evidence, right? So our focus question. Read our focus question together. Go.
How does the number of lines of wire around a core affect the strength of the magnetism?
So, in student-friendly words, that means how many times we wrap it make it stronger or weaker? How do you think we could investigate this? Using the materials you have right here, we're not touching them. Think in your mind, how could we use our junkyard magnets that we've created to investigate if it does make it stronger or weaker, how many times we wrap it? How could we do that? Think in your mind. You can give me a thumb when you know. Talk to your neighbor about it.
Many times you didn't dip it in the system, it might have a tendency to mix up the water. Wrap it up
Okay. So what else could we do?
pick up all the washers, like, wrap it around 90 times. It will be.
All right, give me 5. Someone share out your idea. Your idea. Celine, what's your idea?
Well, my idea is that to investigate it, you can think what you're gonna do first, then try, and if it works, you can write your evidence down how it works.
Okay, you can think and you can write down your evidence, but what are you going to try? What's your idea? What are you going to try, Celine?
Like if you're thinking that you wrap it around the rivet a lot of times, then you'll try that and then you'll see if it works or not.
Perfect. How many other groups said what Celine just said? Celine said you should try wrapping it around a lot of times and see how it works. How many of you said that? Did any of you say more than just that? What else did you say, Avery?
Michaela said if you wrap it around less times, it's better.
Okay, or you could try wrapping around less times to see if it's weaker. Give me a thumb if you agree. All right, that is exactly how we are going to do it today. So hands down. What you're going to do today is you're going to investigate using 10 winds. You're going to wrap your wire around 10 times around your electromagnet. And then you're going to do 30 winds. Give me a thumb if you understand what I'm saying. We're going to go over it more in depth. Okay. What do we have to do? If we're going to investigate this, do we just investigate it and never write anything down?
No.
What do we do? Raise your hand if you can tell me. What do we do, Seth?
Take notes.
Take notes. How do you take notes? What do you write down?
You write down your evidence.
You write down your evidence. So turn to page 40 in your science notebook. We're going to make a T-chart so that we can write down our evidence. You do not need to take up your whole page to make this T-chart because we're not going to have a lot of things on it. Make your T-chart. Yes?
I don't have a pencil.
Okay. Just get a pen. On the left side, you're going to write number of lines. Number of lines. On the right side, what are we counting? How many what? How many what it picks up?
Washers.
Washers. So number of washers. Number of lines and number of washers. How many winds did we say we would start with? How many? 10. 10. So you can go ahead and write 10 right here. How many did we say we would do after we did 10?
30.
30. So you can go ahead and write 30 right here. Can you write how many washers yet?
No.
Why?
Because we don't know.
We haven't investigated. I heard someone say we haven't investigated. So here's our plan. Here's our directions. Let's read number 1 together. Go.
Test the strength of your electromagnet with 10 winds and then with 30 winds. Record your results.
Good. So, what is that? How many winds are you going to do first?
10.
Are you going to do 10 and then 30 and never write anything down?
No.
No. You have your electromagnet. Remember that when you use your electromagnet, you hold up here, right? You do not want to touch down here because it's going to get very hot. Do you touch the part of the wire that's exposed?
No.
No. Why? It's going to get hot and it will burn you, right? Because of the electric current. So, what you're going to have to do is you are going to have to unwrap it first because it was just used by a different class. So unwrap it. Not now, sorry, not now. When you start, do you think you want to start way down here?
No.
You want to leave part of the wire because you're going to have to connect it into your circuit. So you're going to want to start maybe in the middle and wrap it 10 times. Make sure you start up here and wrap it down, okay? Then, after you've done that, plug it into your circuit. What has to be on your circuit for this to work? What has to work? On your circuit, you plug it in, the wires are all plugged in, but what else has to happen that turns your circuit on? I don't know why we're yelling out. Brandon,
You have to use your switch.
what do you have to do with your switch?
You have to turn it on and you have to make sure
What do you mean by turn it on? What's that vocab word?
you have to
Use a what kind of switch?
close switch.
A closed switch, right? So that it can't escape, so the energy's traveling. So you're going to close your switch. When your switch is closed, you can try to pick up your washers. Now, I'm going to hold this up to show you. You're going to pick up your washers. Then, how are you going to know, how are you going to get your electromagnet to drop the washers? What do you do with the switch?
You have to turn it off.
By turning it off, what does that mean? What vocabulary? Open the switch, right? You open your switch and it'll turn it off. I would suggest moving your electromagnet over a little bit so that it drops it in the other tray. Because if you drop the magnets in that same tray, are you going to know how many to count? No. So open your switch, let it drop it, and see how many. Okay? Does anybody have any questions about that step? We're going to go over the rest. Then what do you do once you know how many magnets or how many washers it held? What do you do with that number? What do you do, Landon?
You write it on, you tell your results on a piece of paper.
Good, you record your results, just like a scientist. Then you're going to do 31s, right? All right, what's step 2 say? Go.
Predict how many washers your electromagnet will hold with 20 wands. Raise your hand.
Good. You're going to predict how many washers it will hold with 20 wands. So then you're going to wrap it, or you're not going to wrap it. You're going to look at your data table for 10 and 30. Are you just going to guess just randomly?
No.
Use your data that you have. After you make a prediction as a group, what do?
Raise your hand.
Raise your hand. Should you be testing it if you haven't raised your hand and I haven't come to see you?
No.
No. Let me come to see you first, because guess what? I'm going to ask you why you predicted that. So should you know? You should have discussed that in your group. What's step 3 then?
Test your prediction. Raise your hand.
So then you're going to wind it 30 times, and then what are you going to do?
Raise your hand.
Good. Who has any questions about all 3 of our steps? And 1.
You have to wrap this all the way until it's off the ribbon.
How many times? Do you have to unwrap it all the way? Yes, because how else would you know how many winds you're wrapping it, right? So you have to start. That's a good question, Amon. You're going to completely unwrap this, right? Because you only want 10 wraps. If you don't unwrap it all the way, do you know how many winds there are? No. All right, so yes, you do have to do that. Any other questions? If you get stuck, what can you look at that's going to help you with your steps? What should you always be looking at to know what to do next? Say it.
The smart board.
Good, the smart board. Don't just be sitting there guessing. If I take my time to do this, use it, please. Okay? If you're stuck, you shouldn't have to argue. You should just look. Expectations, read them. Go.
Voice level 2. Stay in your area. Work the entire time. Be respectful.
Remember, do not tell anyone they are wrong. Nobody likes to hear you're wrong, right? Tell them you understand what they're saying, but what you think. Questions? I'm going to put on the timer 20 minutes. That's about probably what it will take you. If it takes you longer, is it okay?
Yes.
But what do you do when the timer goes off?
Stop.
Stop what you're doing and freeze, right? Just wait for more directions. Who is confused? If you start and you get confused, what should you do?
Raise your hand.
Raise your hand. Talk to your group. If everyone's confused, raise your hand, okay? I don't want you sitting there for 20 minutes being confused. Okay? All right. You can go. Good. Now what do you do now? Where's your other one? What do you do with your wires? Make sure they're connected. Good. Make sure you do not close your circuit until you have your wires in. Class!
Yes.
One quick thing I just noticed with A group. Please do not close your circuit until your wires are connected, because if you have a closed circuit and you're trying to connect that last wire, it's going to become very
Hot.
Please do not close your circuit until your wires are fully connected, okay? All right, keep working.
Okay.
Yeah, that should be enough. We gotta do that one. Okay.
Everybody, circuit's closed, fully closed, correct?
It's not touching the battery. It doesn't have to touch the battery.
There you go. Now try. So what should we try doing? If it's not working, what do we need to try? Okay. Good idea. Open the switch.
And let's try redoing this, see if we
Good. So what do you think you need to do with that? Count it again. And what do you need to do with your coils? Make sure they are wrapped how? Tight. Good. The closer they are together, the more magnetism. All right. Did you guys just do 10? How many washers did you get? 5 washers. Good. Did everyone write it down? All right. Make sure you write it down. Why do you all think you only got 5 washers?
Because we wrapped it less times.
You wrapped it less times than what?
30.
Than 30. Is 10 very many times to wrap it? Look at all the wires you have. Is that very many times to wrap it? No. So what do you think? What do you think causes that? The electric field? The magnetic field, right? What do you know about magnetic field and wrapping it less times? Good. So the less times you wrap it, there's not a very big magnetic field, right? Nice job, Anwar. All right, now what are you going to do next? 30 magnets?
30.
Good. Wrap it 30 times. What do you guys think? Is it going to hold more washers or less? Why do you think it's going to hold more? Good. And it's going to get that bigger magnetic field, right? All right, test and see what you find out. Yeah. Remember, you have to hold from the top part to the bottom part of the magnet. Now try. All right, now move it over. Move it over. What do you need to do to make the magnet drop? What do you need to do to make the washer drop? Open the switch. Why do you need to open the switch, Avery? Okay, so if it's still closed, what's happening if it's still closed? It's letting electric current flow. Good. And when you open the switch, what happens?
The electric current will stop.
The electric current will stop and makes the washer drop. Good. How many did you get?
1.
Why do you think it wasn't that many? It wasn't very many wraps, right? What do you know about how many times you wrap it? The more times you wrap it, the stronger it will get, is what you're trying to prove, right? So do you think there's going to be more washers with 30? Why? Say it louder. What? Why? Because what? Good. So it's stronger if there's more water. Write down your data. Alright, what are you guys on? 30. How many did you get with 30? 13. How many did you get with 10?
5. 50.
You got 50?
Somebody got to hold that.
5. Okay, so you had 5 with 10 and 15. Or 13 with 30.
Okay,
Why do you think you had more washers?
Look what it right now. See, that's more times you wrap it, the shorter it is.
How do you know that, Seth?
Because
you wrap the wire around it, the bigger the magnetic field gets.
The bigger the magnetic field gets. So did it have a very big magnetic field with 10 winds? No. How do you know that?
Because it's smaller than 30.
And how many washers did it pick up?
5.
Is that a very big number? No. So now what do you have to do? What's your next step? Do you try 20? What do you do?
No, you do a
Prediction of 20. So, what are you guys predicting? What are you thinking?
They said it will be a little bit like it has to get less than 12 or less than 13. Yeah.
Okay, so you think it's going to be what, Seth?
At least 11 or 12.
At least 11 or 12. Why do you think it's going to be 11 or 12?
Because it's 10 smaller than 30, so then it might pick up a little bit less than 13 washers. So that means since it's 20 and not 30.
Okay, so 20 is less than 30, right? So it's going to pick up less washers than 30, right?
And it's also between 10 and 30.
And it's also between 10 and 30. So use what you know about numbers to predict, right? You guys can go ahead and write your prediction, and then you can try it. Let me know once you've tried it.
You should just be able to
Yes. Remember, when you wrap it, you gotta wrap it really close together, okay? So let me see here. I'm gonna wrap it. How many times did you get to? Okay, so just get as close as you can, okay? So make sure when you start, you're starting pretty close to the end and all the way. You don't want all the extra wire.
24, 25, 26.
Right there. That way you use the most of your wire, okay?
Oh, wait.
Alright, so if you're going to start wrapping it, start here, and then pull this one. That way you're using the most of all of this wire,
You
okay?
can probably get more, but this fell out.
There you go.
Okay,
Nice
try
job.
it again.
Alright, now make sure you move it over so you can count them. Now what do you need to do to make the washers drop?
Close the circuit.
Close the circuit?
I mean, open the circuit.
Why do you need to open the circuit?
Because it's not connected to it.
It stops electric current from flowing, right? And then what happens to the washers?
It drops.
Why? Because what happened?
If the electric current stops flowing,
And what happened to this?
it is a magnetic force. It stops and it drops because the wires are not letting energy go.
Good. So this does not have magnetic force anymore, right? Like Tyler said. So count how many you got. Was this 30? All right. So let's count how many washers do you have.
Okay, it has to be between 1
How many
and
is this?
11.
11. So hold on. Wait a second. We're not predicting it. So if 30 has 11 and 10 has 5, why does 31 get more washers? I can't hear you, Cameron. Because you're wrapping it around more times. So what does wrapping it around more times do? The stronger it becomes. And how do you know that it became stronger?
Because we picked up more washers.
We picked up more washers. And what's around a strong magnet?
It got a magnetic force.
Got a lot of magnetic force and magnetic field. Good. So now you're going to predict 20, right?
Yeah.
So what's your prediction?
20 will probably be between 1 and 11. So
How do you know it's going to be between 1 and 8?
because 10 and 30 is It's two numbers and 20 is right in between them two.
Okay. So what's your prediction?
My prediction, it will be 5 or 6, like that, 5 or 6.
So you have 5 is for 10. So you think it's good? Oh, that's not yours? Sorry. Alright, so you have 1. So you have 1. So you say it's going to be 5? Because this one was 5 or 6. Do you guys agree? Why would you think 5 or 6?
Because it's between 1 and 11, and if they are probably going to work when they're probably going to pick up 5 or 6, it's probably going to pick up that much.
Since it's around like 1 and 11.
Okay. Alright, you may test it. Raise your hand once you tested it. Stuff.
So my best
Okay, one at a time. Hold on. Yes? Your prediction is 8. Why is your prediction 8, Maddie?
Because it's in between 2 and 11.
And why do you think?
10, so 1 less. Well, technically it's 9, but it's 2 plus 9 equals 10. So I'm kind of thinking 16, 7.
Okay, so why would you put a number between those two?
Because 20 is between 10 and 30. No, it's the next 10. You just can't count by 10, 20, 30.
So do you think your 20 wine is going to be as strong as your 30 wine, Max? Do you think your 20 wine magnet is going to be as strong as your 30 wine? Why do you not think that, Max?
Because 30 wines is more than 25,
So what will be stronger?
so 30 wines would be stronger.
So 30 wines would be stronger. What do you know about how many times you wrap a wire around?
As many, the more times you wrap a wire around the lid, the stronger the electromagnet.
Okay, and Brandon, why will it become stronger? Because what's always around the magnet?
The wires?
The wires are around it, but the more times you wrap it, what do we always see around the magnet? What's all around my magnet?
Something you can't see.
Okay, you can't see it. If I had a magnet right here, Brandon, and you were a magnet, it would pull you in towards my magnet. Magnetic field, good. So do you think a 30 wine magnet has a bigger magnetic field than a 10? No, you don't? Do you guys agree? Do you guys agree with what he's saying? What do you think? Help Brandon. Help your group.
Well, the 20 will not have a stronger magnetic field. It's 30.
Okay, because why?
More than 10. And the more times you wrap a wire around the ring,
The bigger the magnetic field will get.
The bigger the magnetic field will get, right? So Brandon, based on what they just told you, which magnet has the bigger magnetic field? 30 does, right? Because the more times you wrap it around, the stronger the magnetic field. Good. So now you can go ahead and test your predictions.
So 1 off, 2 and 1 off.
Okay. Good job. What I want you to do now is I want you to sit independently, and I want you guys to look at this and think about, what do you know? Think about our focus question. How does the number of wires around a cord, how does that affect how strong it is? And based on what you did right here, what can you now prove? Write down under here, independently, okay? What can you now prove? What can you tell me about how many times you wrap it around based on what we just did?
okay.
And what did you predict? Awesome. Okay, now what I want you guys to do is independently, I want you to look at this, your data, and I want you to write down here, what can you now tell me about, what does it matter how many times you wrap a wire around the cord? Do you guys think it does based on your data? Why? Write it right here. Tell me why. We'll discuss it as a class here in a few minutes.
I think it's 8, it's 9, or 10.
Back group, where are you at? So we just decided to sit here because of what it was. Okay, so get as close to 30 as you can. How close do you think you can get?
Don't worry.
Okay, that's fine. Round it. Alright, timer's off, pencils are down. Someone tell me writing about what you can tell me about the number of winds around a magnet. What can you prove now? Does it matter how many times I wrap my wire around a magnet?
Yes.
Why? Why does it matter how many times I wrap my wire around a magnet? Based on your investigation. Why, Maddox?
Because we looked at 20.
Use your loud outdoor speaking voice.
Because we looked at 20 and 10, and they didn't get as much as 30, and 30 had more wraps, so it picked up more washers.
Okay, why did 30 wraps pick up more washers?
Because the magnetic field got bigger by the more wraps around the rivet.
Why does the magnetic field get bigger with more wraps around the rivet? That's a good vocab word, Maddox. Why? Why, Tyler?
It's because you have more energy in flowing it through one area, and it's making a magnetic field, and it's going through the rivet, and it's picking up the washers, and every time that you add add more wires around the rivet, it's going to pick up more washers than it did before.
Good. So did you hear what Tyler said? He had said you have more electricity and more energy in one area, right? What's your area? Your what? Not your what part of your circuit gets more? With more wraps, what part of your circuit gets more energy, Lydell? The electromagnet, right? The more coils you put around that, the more what is going around it?
The magnetic field.
Good. The bigger the magnetic field. If I just had one coil, would my magnetic field be very big?
No.
How can you prove that from your investigation today? If I only put like a couple wraps around it, how can you prove to me that it doesn't have a very big magnetic field? Robert.
Because we wind it 10 times and it got 5 washers.
And what about 5 washers?
It's less than 10 winds.
5 washers is less than 10 winds? 5 washers is less than what? What else did you text, Robert?
30, and it got 13 washers, and 20, and it got 10 washers.
So 10 winds, did it have the most amount of washers or the least?
The least.
Why?
Because it didn't have that much winds.
It didn't have that much winds. And the less winds you have, the less what?
Washers you have.
Washers or the less magnetic field. Thank you, Lydell. Remember, if I don't have very much, my magnetic field's like this big, right? The more coils I add, what happens? It gets bigger. It ends up out here, right? So show me with your arms what you think the magnetic field looked like with your 10 winds. Show me, 10 winds. How big is it? With your arms. Put your arms out like this. Is it this big, this big, this big? Show me 10. I would say probably like right around here, right? Show me now 30. Did it get bigger?
Yes.
Why? Somebody else tell me that hasn't talked. Michaela.
Because it had more winds.
It had more winds. And more winds makes more?
Magnetic field.
More magnetic field. All right. So what I'm going to ask you guys to do is you're going to have to look at a situation where an electromagnet is not working. And you're going to have to tell me why it's not working. Do you think you could do that based on what you did today? Do you think you know what makes an electromagnet work and what makes it stronger or weaker?
Yeah.
I have a question to test if you think you're ready. If Hayden has an electromagnet that has 25 winds, and Angel has one that has 80 winds, which one's stronger, Angel's or Hayden's? Raise your hand. Which one's stronger, class?
Angels.
Why is Angel's magnet stronger? Why is Angel's magnet stronger? Tell your partner. Alright, give me 5. Who can explain? Who can explain why? Why? Avery?
Because the more times you wrap it around, the bigger the magnetic field will get.
Because the more times you wrap it around, the bigger the magnetic field will get. Does that make a strong or a weak magnet?
Strong.
A strong magnet. And who had more times that was wrapped around the cord? Angel did. So whose magnet was stronger, guys?
Angel.
Angels. All right, turn to page 41. Do not write on yours yet. Do not write on yours yet. First of all, before we start, give me a thumb. How do you feel about electromagnets and knowing if they're strong or weak? Give me a thumb. Thumb up. I'm okay. Thumb in the middle. I might need to talk to you for a second. I'm not real sure. Thumb down. No way, Miss Terry. Don't ask me to do this today. Is that in the middle or up? Okay. Middle or up? If you're in the middle, do you have a question I can answer? Or do you just want me to come by and see? Anybody have a question? If you have a question, now's the time to ask it. I can't read your minds. Any questions? Okay. Yes?
I think it's not a good question because we might have not learned it.
Okay. So is it something you need to know to answer this if we haven't learned it? If we haven't learned it, Anwan, would I ask you to do something that we haven't learned? So if we haven't learned it, do you think you need to know it to be able to do this? If we haven't learned it, do you think you need to be able to know it to do this? Probably not, right? Do you have any other questions?
I assume Mary.
Okay, but we haven't read it yet, have we? Okay. All right, so we'll get there, okay? And then if you have a question, let me know. All right, look, point to the top on your page. You don't need to read it up there. It's probably too tiny up there right now. Right here, a student. Ready? Read it together.
A student was trying to make an electromagnet. She found a nail and wrapped a wire around it. She hooked up the wire to a D-cell and switch. She closed the switch and tried to pick up some washers, but nothing happened.
Freeze. Don't read anymore. What I want you to do is with your pencil, mark out these two sentences about this student needs your help and to make a list. You know we always change our directions, don't we?
Yeah.
So we're changing our directions. Okay. Pencils down, eyes on me. Alright, what I'm asking you to do is, the first thing says, analyze the scenario. Scenario situation, right? It's just to analyze what she said right here. Read it closely. And write why you think the electromagnet is not working. Before we start, let me be very clear in what I want. Did we learn about connecting circuits together today? Did we talk about that really?
No.
Did we talk about if a battery's dead or not?
No.
So what did we talk about today that you're probably going to want to talk about in your exit slip? Did we talk about if it's a conductor or not? No. We talked about all that stuff a few weeks ago. Today, I want you to tell me what you know about electromagnets and how strong they are, okay? So when you answer this, are you going to say, well, I don't think she used a conductor? Are you going to say that?
No.
Did we learn about that today?
No.
Apply what you learned today when you do this. So you're first going to tell me why it's not working. You do not have to write the question down, just the answer, okay? So are you going to start writing this question?
No.
Are you?
No.
No. Number 2, what's it say?
Explain what the student needs to do to get the electromagnet to work.
So you're first going to tell me why it's not working, and then you're going to tell me what does she need to do to fix it. You're pretending like you are this student, like I just gave you this situation in class with this and you had to fix it, okay? After you do number 2, raise your hand and I will check it. If you finish number 2 and I have checked it, I will help you move on to number 3, okay? Any questions? Do you have to rewrite the question?
No.
Just answer it. You can close read this passage, guys. You can mark it up if it will help you, okay? All right, go.